Vienna is a pulsating city. More than 1.6 million people live in Vienna, and more than 3 million visit the city on the Danube every year. Vienna is considered to be one of the most livable cities in the world. Many different criteria lead to this top rating by international comparison. Long-term planning in the environmental sector was and is an important pillar of city politics. Vienna is internationally renowned for its waste management. Delegations from throughout the world regularly come to Vienna to inform themselves on location about the city's facilities. Waste management is an aspect in the function of a city that cannot be overlooked, but normally takes place off the beaten track of the tourist attractions. The new waste incineration plant in Pfaffenau can, however, be seen as a new place of interest in the sense of active environmental protection, and is an important step towards the securing of sustainable living quality in Vienna.
In Austria, it is forbidden by law to deposit residual waste untreated on dump sites. With the new waste incineration plant Pfaffenau and the incineration plants that exist already, Vienna assures that residual waste is treated properly and is furthermore converted into valuable energy in the form of electricity and district heat. Welcome, ladies and gentlemen. It's my great pleasure to present the WIP Pfaffenau to you today. Together with the locations Flötzersteig and Spittelau, the new plant deals with Vienna's residual waste in compliance with the highest environmental standards. The routes of transport from waste collection to waste treatment can be massively reduced because all incineration plants are located in the urban area of Vienna. Feeding heat into the district heating network guarantees an optimal use of the available energy. Let us now take a look at this impressive building.
The standards of the plant that was to be newly built in the environmental center Semmering were very high from the beginning. It should result in the emergence of a high-tech plant for the protection of the environment. In addition to highly functional demands and licenses in an environmental impact assessment procedure in accordance with the strictest environmental standards in Europe, it also had to be suitable to architectural and aesthetical aspects. The design of the project is the result of an EU-wide architecture competition. In a construction period of less than 3 years, one of Europe's most modern waste incineration plants came into existence, the WIP Pfaffenau.
The Viennese waste management concept is based on the 3 basic principles: prevention, separation, and utilization. The best waste is, of course, the one that is not produced in the first place. This is why the main focus, in addition to the prevention, is on waste separation. Thus, more than 330,000 tons of waste and biogenic waste is separated annually in Vienna. It is divided into used paper, white and colored glass, metal, plastic, organic waste, and other waste. Only the waste that cannot be recycled requires proper treatment, and incineration is most suitable for this. Now, how does this container get to Simmering? I'm sure you've heard of the Men in Orange.
With more than 3,500 employees, the MA48 is one of the biggest municipal departments in Vienna. In addition to street cleaning, snow clearing, and the municipal fleet of cars, it is especially responsible for waste management. 365 days a year, the employees of MA48 go to great lengths to keep the city clean and to collect the waste that every individual has produced. The journey to Simmering can now begin. The transport of the non-recyclable waste to the plant takes place with collection vehicles from MA48 mainly via the highway. Roughly 770 tons of waste are delivered daily. Now a special kind of relay begins. When entering, the waste collection vehicle is weighed and after approval by the traffic light can drive to the tips of the waste bunker. A total of 12 tilting spots are available for the valuable load. The tips are equipped with flaps in order to prevent smell and dust disturbing the surrounding area. These are only opened during the emptying procedure. Welcome to the storeroom with special dimensions. 15 meters wide and 72 meters long, it can store 18,000 cubic meters of waste, which corresponds to an average load of 1,800 waste collection vehicles. This is the crane operator's territory. He controls the undisturbed procedure in the waste bunker, makes sure that the waste is well mixed, and navigates the waste crane with a smooth touch towards the incineration charging bin. Now it is going to get really hot. The burning waste is transported downwards by slow pushing movements of the grate. The air necessary for combustion is fed through the openings in the grate as well as directly into the incineration chamber. The firing temperature in the flame rises to more than 1,000 degrees centigrade. After roughly 1 hour, the combustion process is completed. Approximately 30% residue of combustion, consisting mainly of non-flammable elements like slag, ash, scrap, and stones, accumulate on the grate side. The residue of combustion must be further treated. The scrap is separated with the help of metal separators and is used in the metal industry. The slag is solidified together with the ash into ash slag cement in the waste treatment plant Vienna, which makes the environmentally compliant deposit in the city's dump site possible. Let's return to the plant. Now an 850 degree centigrade heat wave climbs up the waste heat boiler. Here the heat energy from the hot flue gas is transferred to the water in the boiler. The flue gas successively flows through the various components of the waste heat boiler, the so-called flues. In the first part, the empty flues, the walls are equipped with pipes. The boiler water circulates in them. The flue gas delivers the energy to the water, whereby this heats and rises to the top and the flue gas is cooled. After the empty flues, the second component follows, the boiler flues. Additional contact heat surfaces are deployed here. The preheated water is channeled once again through pipes and thus repeatedly heated until it evaporates. The steam created is the basis for the production of energy. More about this later. The flue gas has cooled down step by step from the original 850 degrees down to 250 degrees centigrade. The last component is the economizer. The remaining temperature is used to preheat the water in the boiler. Thus, the energy is used to a maximum. The ash accumulated in the waste heat boiler is collected in funnels and deposited in the ash silo.
The steam developed in the waste heat boiler is used for the production of electricity and district heat. The steam drives a turbine and thus generates mechanical energy that is furthermore converted to electrical energy in a generator. This is then fed into the public electricity network. Hence, 25,000 Viennese households can be supplied with electricity. The steam taken from the turbine is used for the generation of district heat. It condenses to water in a heat exchanger and delivers its heat energy to the district heating network of the city of Vienna. This energy covers the heat demand of 50,000 homes. By using the heat energy that develops due to the thermal handling of the waste, the degree of efficiency is 76%. Parallel to the extraction of energy, the fight with the flue gases starts now. This fight lasts for 4 rounds. First of all, there is the electrostatic precipitator. It is used for the removal of dust. In round 2, the toxic acids are rinsed out of the flue gas in a 2-stage scrubber. Round 3 starts with the active coke filter for the separation of organic toxics. The fourth and last round takes place in the catalyzer, where the nitrogen oxides are removed. But let's have a look at this now in detail. Let the fight begin.
Round 1. the electrostatic precipitator. The flue gas coming out of the waste heat boiler reaches the electrostatic precipitator. Here, plates and frames are alternately mounted. Emission electrodes under high tension are placed in the frames. The flue gas flows through the electrostatic precipitator, and the dust particles floating in the gas are electrically charged by the emission electrodes. Under the influence of a high-voltage electric field, the negatively charged particles of dust are attracted to the positively charged plates, the so-called precipitation electrodes. In order to clean, the plates are made to swing mechanically, whereby the dust falls into the collecting funnels underneath the electrostatic precipitator and is transported from there to the ash silo. After further treatment, the ash is also deposited together with the slag on the city's dump site. Round 2. The wet scrubbers. Time for a shower. The basic procedure in this cleaning round is the rinsing of toxics with water and lime milk. In the first scrubber, water is sprayed in by jets. In the process, chlorine and fluorine compounds, but also heavy metals, are washed out of the flue gas. In the second scrubber, lime milk is sprayed in instead of water in order to separate the sulfur dioxide. The lime milk reacts with the sulfur dioxide to a gypsum suspension that is continually extracted from the scrubber. The washing water is cleaned by the plant's wastewater treatment and then subsequently fed to the main wastewater treatment plant in Vienna. The solids that remain after the wastewater treatment are the so-called filter cake and gypsum. The filter cake is deposited underground. Gypsum can be processed for use in industry. Round 3. The activated coke filter. Off to the coke chamber. The cleaning principle of the active coke filter is very simple. The flue gas flows through several layers of special brown coal cokes, and the toxics can accumulate on them. The coke used has a multitude of fine pores with a surface of 300 to 400 square meters per gram. This is equal to the size of about 1.5 tennis courts. This fine pore system is especially suitable for the adsorption of gaseous toxics and very fine dust particles. Because the adsorbency of the active coke is depleted after a while, the used active coke is continually replaced by fresh coke. The used coke is incinerated. Round 4. The Denox unit. Now fast reaction is necessary. Unwanted nitrogen oxides are removed here. Before entering the Denox complex, the flue gas is sent once again through a heat exchanger and heated to a temperature of 180 degrees centigrade. Now ammonia water is added to the flue gas by means of jets. After mixing well, it moves on to the catalyzers. These cubes made of porous ceramic have a multitude of thin channels through which the flue gas can flow. On the surface of the catalyzer, optimal conditions prevail for the chemical reaction that allows the mixture of nitrogen oxides and ammonia water to become harmless nitrogen and water vapor.
At this stage, the flue gas cleaning is completed, and the pure gas is dispersed via the chimney at a height of 80 meters. The clean combustion air that leaves the plant is put through a stringent test. Samples are taken at 2 test points in the chimney, so the quality of the flue gas cleaning can be continually checked, and the result is not bad at all. The new WIP Pfaffenau is 90% lower than the allowed limit for dust exposure. The WIP Pfaffenau is therefore another substantial contribution to extending Vienna's leading position in protecting the environment. All right?
Responsible handling of the waste that we all produce every day. The city of Vienna stands for this, and the WIP Pfaffenau is the best example. High tech for the environment, so the high quality of life in Vienna is preserved for generations to come. Vienna is one of the most beautiful and cleanest cities in the world and extracts energy from non-recyclable waste.